This assessment asks us to choose an alkene that, if reacted under hydroboration oxidation conditions, would give us the alcohol shown. In order to answer this question, first of all, we recognize that this is going to be the product of a hydroboration oxidation reaction because our alcohol that we've produced is at a secondary carbon. So it's at the least substituted carbon. It is an anti-Markovnikov alcohol. But that implies that we could have an alkene between these two carbons or between these two carbons. And how do we make that decision? Well, the way we make that decision is let's draw in the hydrogen. So if we draw in the hydrogen that's at this carbon, forgive that it might be misplaced by a bit because of the Weatherman effect, and we draw in the hydrogen at this carbon, right here, what we notice is that this hydrogen here is on the opposite side of the hydroxyl group, whereas this hydrogen here is on the same side. The hydroboration oxidation reaction results in synaddition of H and OH. As a result of that, we know which alkene it must be. We must start with this alkene as shown. This is going to allow the synaddition of H and OH through the hydroboration mechanism to give the stereochemistry indicated there.